स्टार्ट करें या कोई बाहर में? मूवमेंट, स्लाइड मूवमेंट itu right? No. Slide ketemu. Itu mesti slide movement no. Slide movement तो ठीक है। ये सब slide को मैं हिट ही दिया तो फर्स्ट स्लाइड तो जो है नहीं। स्लाइड मूवमेंट इसमें कर सकते हैं? इसमें भी नहीं हो रहा है, इसमें भी नहीं हो रहा है। ये देखिए मूव नहीं हो रहा है। इसमें हो रहा है। हैवी है ठीक है। इंसान ऑल ऑफ So good afternoon everybody. Already we have heard about the basics of hydrogeology. Now we'll discuss something on artificial recharge. Why the artificial recharge requirement comes up? Because if you see, it is yet to be finalized for resource estimation. The figure, if you see, in most of the cases, slowly it is going on overexploited or critical stage. That is, the resource what is available with us, it is going down. So it is creating problem. Already in Guwahati city also we can visualize the crisis, because most of the people are now purchasing water, and this is not the scenario for Guwahati city only. In a number of urban areas this type of issue is coming up. 2 point is there: source and resource. Resource may be there, but in your source, resource may not be there. That is the issue. It is coming up in northeastern region. Water is sufficient, but in some sources, previously it was taking giving sufficient water. Now it is slowly diminishing. So there comes the issue. So rainwater harvesting, artificial recharge to groundwater, and water conservation. 3 approaches we can do to resolve our issues. Say rainwater harvesting, as know the technique of collection and storage of rainwater at surface or in subsurface water bearing zones before it is lost as a surface runoff. Where we'll go for surface or where we'll go for subsurface conservation, that harvesting, that I will come later. Then artificial recharge. Recharge is happening naturally through rainfall. We are getting the recharge, but when the natural process through which we are getting the recharge of the aquifer is not sufficient, then intervention or artificial recharge will be required. Then water conservation. It may cover the both surface and groundwater conservation from pollution also. So you can go line by line. It is not required to read each line. Anything else? Any issue? It's okay. So increase the availability of groundwater during periods of requirement, enhance sustainable yield of aquifer, improve quality of groundwater, arrest declining trend, prevent depletion of groundwater, decrease minimize of floods on local and regional scale, reduce pressure on storm drains, enhance the quality of environment. This is the slide more issue is coming. This slide is not moving properly. See, if I select also, it is creating problem. Then subsurface storage space is available free of cost and inundation is avoided. Evaporation losses are negligible if you go for subsurface. It has no adverse social impact such as displacement of population and all. Temperature variation becomes minimum, biological purity is very high, it is environment friendly, relatively immune to natural and man-made catastrophes, natural distribution system between recharge and discharge points. One point is important here, 1 meter rise in water level saves 0.4 kilowatt of power. So, if you can do, we can rise through any way, through artificial recharge, here I will speak, then it will save 0.4 kilowatt of power. That means you will save also some money. So, here with one scenario I am talking, draft, or presently we are generally used to say extraction. Extraction, if it is greater than recharge, what situation will come up? Lowering of water level. What will be the management option? Supply side management, that is increase recharge we will have to go for, or demand side management, decrease the extraction. So, in majority of the cases, demand side management, it is a very difficult time process, because if the population is rising in any city or any area, alternative issue is how we will save water. So, that point for agriculture or any purpose, nowadays we are talking about sprinkler irrigation, this way or that way, somewhere we will have to reduce. In one we will have to look on that, how we will reduce the demand, and another the intervention to recharge or to raise the water level. Site selection and artificial recharge planning. Site specific planning based on local hydrogeological condition. So, in everywhere, every structure is not feasible. Its hydrogeology is important, demarcating the area of the reserve, prioritize the area, whether the area is feasible, then normally taken up in the areas where groundwater is declining on regular basis. Unnecessary everywhere we will not go for recharging. There must be some reason. Water level is declining, so groundwater is declining on regular basis, aquifer has been desaturated, availability is inadequate in lean period. In the dry spell you are not getting the water, area of salinity ingress of cooling, this is not at presently not an issue for the northeastern region. Rainfall is sparse over large number of rainy days, availability of non-committed surplus runoff. These are some of the issue. With that, another scenario I am showing. Here should water be stored or recharge? So, what we will do? So, just see the rainfall pattern like Kerala, Mizoram here. Periods between spell of rain is short. So, here almost in every day we are getting some amount of water. So, what we can go? We can depend on domestic size water tank for storing water. We are having rainwater, short spell we are getting that. So, in a domestic site container, as per our requirement, we can store that water and utilize. But if the scenario change in rainfall pattern, say in Rajasthan, Delhi, Odisha, you can see in most of the period there is almost negligible rainfall, and for a short span of time there is a huge quantum of rainfall. So, within a short span of time, if I give you huge amount of water, where you will store that? You have limited space in your household, that where you can store. So, we will in that sort of case we will have to think for recharging that water beneath there is a huge space if it is available, where from as per our requirement we can take it out and utilize. Now, with a slide I am showing here. So, based on post monsoon depth to water level, if we have to go for recharging, we will have to see the post monsoon depth to water level. Here you can see 3 color I have given. This is the portion, can you hear? Can you see this? Within 3 meter water level, it is 3 to 5 meter, and this yellow portion is 5 to 9 meters. So, if within 3 meter water level already existing, and if you think for going for recharging, then water logging condition will create. So, we will not go for. And one term is given, why post monsoon? In pre monsoon water level generally falls, then naturally it replenishes and comes up in the post monsoon season. In post monsoon season also, if the water level is at depth, very depth, so then only you will go for recharging, otherwise it is not required. Normally it will be recharged. In Brahmaputra plain also, in most of the time what thing happens, some places it may go in the bordering area where gravelly formation is there, in the dry spell it may go up to 8-9 meter, but with the rainfall it will suddenly rise water level and it will come closer, say within 4-5 meter. So, if this type of condition happens, it is not required. So, here from these 2 area we are choosing 3 to 5, more than 3, less than 3 we are not considering, 3 to 5 and 5 to 9. 2 areas we are giving, say the total area of this basin is 250 square kilometer. Out of that we are getting now the 244.05 square kilometer. We have excluded this area. We are not going to implement any recharge mechanism here. Now, whether long term water level trend is falling or rising, what CGW is doing, we are monitoring the water level, monthly water level monitoring. If you plot all this data in Excel and make a curve, you will find that there is declining or increase in water level. The first slide here you can see that green line trend of post monsoon. What you can see, 0, 1, 2, 3 here written on, it is the depth of water level. So, here the year is given. So, here from 19 to 24 if you go, you can find that this green line is going down. That means water level is going down. So, trend is this, that water level is going down, and here water level is going up. So, this type of 2 scenario may happens or may be stable, may not be a huge fluctuation in the post monsoon. So, now we are considering in this picture that these are the belts where water level is, this green portion with my cursor movement you see they are less than 0.2 meter, it is trend, it is going down, water level is going down, per 0.2 meter per year it is declining. In this portion plus minus 2, that means somewhere it is declining, somewhere it is increasing, and this portion upper portion plus 0.2 greater than 0.2, that way it is increasing, coming up. Now, area we have divided, how much area we can calculate. If we plot in any map, we can calculate the area from here. From there we are segregating first the area where we will go for recharging. So, this HS mark the whole area we are considering, and this portion where it is rising, it is not required. But in this portion it is, though rising it is showing, but it is more than 6 to 9 meter water level. So, initially we are considering, rest we will check with other things and we will finalize whether we can consider or not. Now, if you see the geology of that area, then most of this portion is massive shale. In massive portion hardly you can go for recharging. So, we will have to exclude that part and the rest of the portion excluding this portion where water level is within 3 meter will not go for recharge, and that portion we can go for recharging. Is it up to that? Is it clear? One by one step how we will choose the area. Now plot both these things, your geology and this area earlier chosen. From that area, this whole portion yellow earlier chosen, now it is showing from geology that it is very hard, compact. So we will not choose for recharging. So rest remaining area other than HS, from on that area we 166.8 square kilometer approx, on that we will go for recharging. So that way we will plan for area to be recharged. Now the Beddoes volume, that how much space is available for us to go for recharge. For that, first of all, based on our formation, we have calculated 3 to 6 meter how much area is available for shale, limestone, all area. Those area as per geologically and where water level is declining, that area we have segregated. Now the zone, suppose in this 3 to 6 meters, somewhere it may be at 5 meter water level, it may be at 4.5 meter water level. So below 3 meter average water level, if you subtract, then you will find say 1.5 meter, that is gap, that area is available where we can recharge. Okay, because one point it may be something, another point it may be something, but in the field you will have to go for a broader area for recharging. Point wise you cannot think, because in subsurface that much portion of Beddoes area is available where you can go for recharging. With that you will have to multiply the specific yield that he has discussed earlier. Okay, so it is coming 10 MCM almost volume is there. With that you will have to multiply 1.33, because we are considering 75% efficiency with that. If it is 75% efficiency, because non-committed surface runoff, because water from where you will take? From surface runoff. There may be some committed. Which one is committed? Already you are having pond or any structure already you have kept for recharging. So that is your committed. Other than this, whatever water will remain, that is non-committed water. From that, whatever is the requirement, more than that, we will take reciprocal of 75%, that means reciprocal 100 by 75, from that 1.33 will come, because exactly with that amount you cannot go for recharging, there will be losses. Sometimes it varies. Generally concept is that 75% efficiency we are considering. If somebody thinks no, in my area more efficiently I can do 90%, he can take. So runoff how will estimate? Because you have chosen your area, you will go for recharging, but what is, where from you will get the water? That is the surface runoff. That water you are going to recharge, whether how much water is available. Say average monsoon rainfall, say of an area is 1147 millimeter. That you can gather from anywhere in your area. What is the rainfall in your? So I have converted into meter, 1.147. The percentage of runoff to rainfall as per Stranger's table. For that you will have to follow one table, that is known as Stranger's table. If rainfall is this much, how much average, if you consider an average catchment area of that, how much will be the percentage of runoff you can consider. So based on rainfall it is given here, it is 1168, or hour is 1147, that is nearby, approximation, that much amount of you can take. So from there you can find that the depth of runoff due to rainfall is 38.08 centimeter or 0.3808 meter. That is that percent of your rainfall, 33.2% of 1.147 meter. From that rainfall, that much you can plan for your recharge. So total yield of runoff generated from water state, how will calculate? That is for one point, no? this much rainfall, that much percent, everything is for a single point. For what is was your area? 250 square kilometer your area. So on 250 square kilometer area, if you convert and multiply with that, you will get that approx 95.19 million cubic meter of water will be available, and 30% of the total runoff, that is 28.557 MCM, is considered as surplus monsoon runoff available for artificial recharge. So from here, from your area, you are finding that around 28 MCM of water is available for recharge, and your requirement is 13.3 MCM. So with that you can do. Is it okay? So that way, first identify the area, second calculate the volume of water, whether it is available or not. And there you remember to calculate first the committed runoff, that is already you will have to keep, already you have committed, then non-committed water how much, with that you will have to plan. So ultimately, based on that, this HS mark area we are excluding from for artificial recharge. Rest of the area you can plan for different type of structures. The way you can plan for recharging, that varies on topography of the area and other things also. So here what will be the intervention? There will be lectures on springs. Here they will explain. Just briefly I am touching this point, that if the slope is high, around 25% or 14 degree, and in that area if your springs are drying, then you can go for staggered trenches. If it is more than that, slope is more high, then you should go for afforestation and other activities, because all structure everywhere you cannot put. The water pressure will break up all the structures and it will not serve your purpose. So detailing will be done by other lecturers which will. So on slope 10 to 20% contour trenching, on slope less than that earthen contour bunding. Only the percentage of slope we are considering that it should be stable for that structure, otherwise it will break down all these things. So just for visualizing, I am giving what will be the slope, what will be the staggered trenches, and what will be the sizes, length, breadth, depth. Then nala bunding, just read through that. Catchment should be 40 to 100 hectare, width of nala should be 5 to 15 meter, flow in the stream channel is retained on pervious soil. If it is not pervious, then what thing will happen? It is useless, only for storage. From there you can supply to your nearby agricultural field. That will not serve your purpose for which you are planning for recharging. Okay. So in very brief I am going ahead. So this is one structure from Meghalaya I am giving. This is a Meghalaya picture. Here this is the one check dam they have prepared. Sometimes here they have not built this check dam for recharging part. It is for storing and utilizing in the agriculture field. These white patches what you are seeing, these are all staggered contour trenches they have prepared for recharging the area. So based on slope and your requirement and availability, you will have to plan in your area what, where and for what purpose you will do. Is it clear? Like the gabion structure across small streams, locally available boulders, mass and steel you can construct. Height around 0.5 meter, except overflows. This structure storing some water to serve as a source of recharge. Excess water we are allowing because excess water to be flowed. What is the requirement? That only we can store, not the huge whole quantity. Whenever we are estimating the groundwater resource, we are keeping some natural discharge, that we are not considering for our resource calculation, that will be utilized or we will go for any planning for any purpose, because for our ecosystem some amount of water is required to be flowed, kept for drainage or any other natural water supply system, there water should be there. So here also excess water will be flowed, and seal content, everything what it will be deposited here, slowly it will be compact and it will be a stable structure in time. Temporary, where you can prepare, I am showing this picture. Now these are some scenario from Guwahati area. So these blue patches what you see, these are your aquifer. Okay, this clay portion is grayish color. Okay, so two situation may arise. If you think, if say water level is, see there arbitrary line I have drawn just for showing you that around 35 meter this water level is going. So what we will do here or here and here? Here it is very close. Overburden or whatever be the thickness, say within 2 meter or 3 meter is there, then through construction of small diag wells or recharge pit we can plan. But if it is more than 30 meter, 40 meter, then we cannot throw these small pits, you cannot do. You will have to construct some tube well through which you can go for recharging. So this type of section is required for that only. Hydrogeological section is required where what type of structure. Here if you construct any dug well through recharge, if you plan for that, your aquifer is far away. So in clay, how will you recharge? You cannot do, no. Another section you can find that Fatasil Ambari area, here huge thick clay layer is there, and after that you are getting a good saturated aquifer. Saturated, maybe unsaturated, but aquifer, presence of aquifer is there. But if in this area water level has gone down, say 30 meter, 40 meter or 50 meter gone down, then you can go for recharging, but in that case through small pits and all you cannot do. So you will have to go for borewell construction, and through that you can go for recharging. Earlier I have shown for catchment area how you will plan. If you are available any rooftop area, from there also you can go for recharging. But remember one thing, filtration to be given first, because if any seal particle starts to flow within a year, it will start to clog the filter, and after that you cannot do anything. Again you will have to construct. So pictorial diagram, if you like to see, you can see from the roof area through filtration system we are passing for recharging different porous formation, that is the aquifer. Here also section is given. Here what thing we have done, this filtration chamber is kept outside, and through filtration we are passing. And in next slide what we are planning, that filter media will be just surrounding the well. Filter media water will pass through this media, and through this there will be some holes will be kept for water to percolate, and it will go down for recharging. If aquifer is very within 2-3 meter there, then through dug well also, if in dug well water level is going down, then you can go for recharging through your existing dug well or through construction of dug wells and all. So wells that were initially productive but have become defunct due to decline in water level can choose be wells that are collapsed or wells that are abandoned due to poor groundwater quality. These are some of the structures. Everywhere you cannot go for constructing of recharge structure. If it is already available, any structure is there, you can go for recharging this. This is through dug well. I'll 2 video is there, almost over. So just see whether it opens or not. I don't know. क्या हो गया? here for research purpose, if you are interested, you can put one flow meter, that what is the quantum of water you are recharging, and if you can install DWLR with telemetry system, also you can record what is the water level condition, whether it is rising, what thing is happening, that record also you can check. And another, just for your showing, generally see, for recharging anything can be done. Just see how they are recharging. Fast shower should be avoided, dirty particles may be there. After that, they don't have any roof area, nothing is there. Then also they are trying to recharge the air. This is one example. Okay. For which? So through filtration media we are passing, and any water you cannot recharge. Remember that you are recharging in a point, but beneath the surface it is not your jurisdiction. From here you are also taking, you may be also taking from that water. So if you contaminate in any area, that will create problem. So that you will have to well taken care of. वो डागवेल का ये फिल्टर मीडिया, फिल्टर बाहर में आपने आपका साइड में बना लीजिए, कोई तो फिल्टर करेंगे ना, तो फिल्टर करके इसमें कर सकते हैं, या डागवेल का साइड में भी बना सकते हैं फिल्टर मीडिया. It depends upon availability of space, availability of money, so many things will come up. So where whatever possible you can do, you can from your roof area, if water is coming, that you pass through a filter media. Then if it is dug well is nearby or tube well, anywhere you can put. Where? There may be some here first shower is not required. Tapan sir, I think first shower is not required here for roof area. इसमें भाल्व रहता है, भाल्व रहते हैं, भाल्व से फास्ट शावर को आउट कर सकते हैं. कौन सा? हाँ. ये केस में तो जाएगा ही नहीं, क्योंकि यहाँ पे 3 टाइप का फिल्टर ही लगा दिया ना. सैंड आ रहा है, मीडियम साइज आ रहा है, देन बिग साइज पेबल दे रहे. सो फास्ट शावर से लेके या जहाँ जो आएगा दैट विल बी ब्लॉक्ड. Yes, but you will have to think for from where the water is coming, whether it is from roof water or it is from some drain you are draining. Then there may be a problem. Silt may not be there, but already in quality aspect it may be contaminated. शिलोंग में भी काफी एरिया में पूरा रूफ एरिया है, सारे पाइप है, सब कुछ है, अल्टीमेटली जाके ड्रेन में फेंक दे रहे। देखिए आप शिलोंग बोल के नहीं बोल रहे, कोई शिलोंग का होने से खराब आ जाएगा भाई, मेरा एरिया के निगेटिव बोल रहे हैं, लेकिन मैं रह के आया 7 साल में, देखा पूरा सारे अरेंजमेंट है, सिर्फ उसको लाके थोड़ा सा पाइप दे के फिल्टर मीडिया से नहीं, तो इसको एडवोकेट कर रहे भाई, पैसा ज्यादा मत खर्चा करो लेकिन काम कर लो। एनीथिंग एल्स? कर सकते हैं, कर सकते हैं, लेकिन वही 2-3 आदमी को एक साथ राजी कराना, पैसा कौन कितना देगा पहले तो क्लियर करना है भाई, सबका बेनिफिट होगा, ये मेरा जमीन नहीं है, नीचे सबका जमीन है। ये एक रिपोर्ट है, ये रिपोर्ट दे देंगे आप लोग को, वो थोड़ा देखिएगा, सिंपल एंड प्रैक्टिकल मेथड ऑफ आर्टिफिशियल रिचार्ज, थोड़ा रीडिंग मटेरियल उसमें थोड़ा सिंपल लैंग्वेज में, थोड़ा सिंपल पिक्चर में बहुत सारे मेथड दिया, बिकॉज ये लेक्चर में सारे स्ट्रक्चर से लेके बात नहीं कर पाएंगे। वेबसाइट से मैं लिया, मैं रेडी लेके आ गया ताकि आप लोग ग्रुप में शेयर करके इसको देखें। ओके,